because every spring has an elastic limit, which means if you put, let's say, 100 grams, it will displace. If you put 1,000 grams, it can break the spring, right? It may break the spring depending on the weight. So as long as the elastic limit of the spring or the elastic object in this case is not exceeded, force is directly proportional to the displacement. However, we are talking about the restoring force. In this case, it's going to be negative because it pushes it backwards. However, if we want to remove this sign of proportionality, what do we do? In maths, if you want to remove the sign of proportionality, what do we do? Any idea? Okay, you introduce a proportionality constant. That's very important. And this sign is used to represent sign of proportionality. So in this case, to remove this sign of proportionality, we still have our restoring force equal to Ks, where K is the proportionality constant. It can be C, it can be any other variable letter you choose. However, with respect to spring, it's actually called spring constant. And it varies from one spring to the other, depending on, first of all, the material the spring is made of. That's number one. Number two, the diameter. Do you understand? So the material of the material with which the spring is made of, and also the diameter and how close they are. So, however, if we keep working on this equation to remove this negative sign, we're going to have our restoring force to be equal to minus Ks. Please remember that this negative sign only indicates the direction where the force is going. The proportionality constant of a spring is what? It's a positive number. This only indicates the direction, please. Don't confuse it. Does that make sense? Any question? Okay. Now we are going to look at one material. This material is from this book. So can you help me distribute it? Then we're also going to look at a problem in your test. If you have your textbook on page 370, do you have it? Okay. On this book, if I knew, I would have printed the question. Anyway, but I'm going to summarize the question. On this book, it says, if a mass of 0.55 kilogram attached to a vertical spring, that's a vertical spring. The spring 2.5 cm from its original equilibrium position. This is the original equilibrium position. Then it displaces what? S equal to 2.0 cm, centimeters, from its original position. What is the spring? What is this K? That's what they want us to find. Does that make sense? If the mass of 0.55 kg attached to a vertical spring stretches the spring 2.0 cm from its original equilibrium position, what is the spring constant. So they actually wanted us to find this. K. So now to do that, all we need to do is to use this very formula. But if you look at this formula, there is no mass there. However, there's another formula that has to do with mass, and that is this one. So you can actually call this equation 1 if you want to, and call this one equation 2. Does that make sense? So in that case, if this thing is a vertical spring, which is what they described, it's going to be mass times acceleration equal to minus Ks. Remember, our acceleration this time around is acceleration due to gravity. Does it? What's that? 9.8. Excellent. 9.8 what? Meter per second squared. Yes. Always remember the unit. So in that case, we are going to use mg equal to minus Ks. And then that will be our equation 3. Now we know the mass, we know the acceleration due to gravity. We also know the displacement. However, the displacement is in centimeters. So we have to convert that to what? Meters. So what do we do? Apply by? Is it diagram on the piece of paper I distributed? On the back. So, and that will give you what? Minus K multiplied by what? 0.02 meters. So if you just make this the subject of the formula, do you remember that? To make the subject of the formula. Eliminate every other number but K. Divide by what?
0.02 meters.
Excellent. So if you divide both sides by 0.02, you are going to have 0.55 kg multiplied by 9.81 m by s squared all over 0.02 m equal to minus K multiplied by 0.02 all over 0.02. So when you do that, what happens?
It cancels.
This cancels out, thereby leaving you with this. And in that case, you can now use your calculator to just multiply these two numbers and then divide it by this.
Wouldn't it be negative 269.5?
Minus 269.5. Now remember the units. So what is it going to be in this case? Kg per what?
No, second squared.
Yes, and that what was that? Kilogram per second squared. It's Newton. It's actually a force, and force is measured in Newton. Does that make sense?